In this video, we're continuing on with the Solving Absolute Value Equations worksheet on the KutaSoftware website. And you can find this within the Equations and Inequalities section under the Infinite Algebra 2 tab. So picking up with number 10, we need to get the absolute value all by itself. Because remember, the absolute value of x is the same as the absolute value of negative x, which is equal to x. So that means whatever is inside the absolute value can be either positive or negative and result in the same answer. So once we get the absolute value by itself on one side of the equation, we can see what number that's equal to and then can solve for when the inside of that absolute value is negative or when it's positive. So for number 10, we're going to isolate the absolute value of v plus 8. We're going to do this by adding 5 to both sides. So I'll get the absolute value of v plus 8 on the left-hand side, since negative 5 plus 5 equals 0, and 0 plus any quantity is that quantity, and then 2 plus 5 is 7. So the absolute value of v plus 8 equals 7. That means that v plus 8 is either positive 7 or negative 7. Since the absolute value of 7 equals the absolute value of negative 7, which equals 7. So now we'll have two separate equations. V plus 8 equals 7, or v plus 8 equals negative 7. When v plus 8 is positive 7, we'll subtract 8 from both sides to get that v is equal to negative 1. When v plus 8 is equal to negative 7, we'll subtract 8 from both sides to get that v is equal to negative 15. So v can either equal negative 1 or negative 15. And that's the solution in number 10. And you can see that if we plug negative 1 in for v, we'll have the absolute value of negative 1 plus 8 minus 5. That equals the absolute value of negative 1 plus 8, which is the absolute value of 7. And we're still subtracting 5. The absolute value of 7 is 7. So 7 minus 5 is indeed 2. And when we have the absolute value where v is negative 15, we'll plug negative 15 in for v. We're still adding 8, so we're taking the absolute value of that quantity and subtracting 5. The absolute value of negative 15 plus 8 is the absolute value of negative 7, and we're still subtracting 5. That's equal to 7 minus 5, which we know is indeed 2. So you can see that if v is negative 1 or v is negative 15, then our equation is true. Let's move on to number 11. In number 11, we have the absolute value of 5x plus 5 equals 45. So I have to isolate this absolute value. We're going to do that by subtracting 5 from both sides. So we'll get that the absolute value of 5x equals 45 minus 5, which is 40. So that means this quantity, 5x, either equals 40 or it equals negative 40. So let's set up our two separate equations. 5x equals positive 40 or 5x equals negative 40. For when 5x is positive 40, we'll divide both sides by 5 and get that x is equal to 8. When 5x is equal to negative 40, dividing both sides by 5, we get that x is equal to negative 8. So for number 11, x is either 8 or negative 8. Because the absolute value of 40 equals 40 and the absolute value of negative 40 also equals 40. Moving on to number 12, remember we're trying to isolate this absolute value. So we're going to do that almost similar to how we would solve for a variable. So we're going to subtract 8 from both sides to get that 3 times the absolute value of negative 8x equals 80 minus 8, which is 72. Now we're going to divide both sides by 3 in order to isolate that absolute value. 3 divided by 3 is 1. 1 times the absolute value of negative 8x is the absolute value of negative 8x, and that's equal to 72 divided by 3, which is 24. So now we can say that negative 8x, that quantity inside the absolute value, either equals positive 24 or it equals a negative 24. Since the absolute value of 24 is 24, and the absolute value of negative 24 is also 24. So we have our two separate equations. Negative 8x equals a positive 24, or negative 8x equals a negative 24. When it equals a positive 24, we'll divide both sides by negative 8 to get that x is equal to negative 3. When it equals a negative 24, we'll divide both sides by negative 8 to get that x equals a positive 3. So our solution in number 12 is negative 3 or positive 3. In number 13, remember we're isolating the absolute value. We're going to start by subtracting 5 from both sides. In doing this, we'll get negative 8 times the absolute value of negative 2n equals negative 80. Then, we'll divide both sides by negative 8. Negative 8 divided by negative 8 is a positive 1, and 1 times the absolute value of negative 2n is the absolute value of negative 2n. And that's going to be equal to negative 80 divided by negative 8, which is a positive 10. So that means that the quantity within the absolute value, negative 2n, is either equal to positive 10 or it's equal to negative 10. So we'll set up our two separate equations. Negative 2n equals positive 10, or negative 2n equals a negative 10. When 10 is positive, we'll divide by negative 2 on both sides of our equation to get that n is equal to negative 5. When 10 is negative, we'll divide by negative 2 on both sides to get that n is equal to positive 5. So for number 13, our solution is negative 5, positive 5. In number 14, in order to isolate this absolute value quantity, we're going to start by dividing both sides by negative 5. Negative 5 divided by negative 5 is 1, so we'll have the absolute value of 3 plus 4k on the left-hand side of our equation, and that's going to be equal to negative 115 divided by negative 5, which is a positive 23. So that means that 3 plus 4k equals 23, or it equals negative 23. So setting up our two separate equations, 3 plus 4k equals positive 23, or 3 plus 4k equals negative 23. I'll start by subtracting 3 from both sides when 23 is positive. That'll give me that 4k is equal to a positive 20. When I divide by 4, I get that k is equal to 20 divided by 4, which is a positive 5. When the 23 is negative, I'll subtract 3 from both sides to get that 4k equals negative 26. Dividing by 4, I'll get that k is equal to negative 26 fourths, since 4 does not go into 26 evenly. However, this can be simplified. Since both are even numbers, let's divide the numerator by 2 and the denominator by 2. So we'll get that k is equal, dividing 26 by 2 will be 13, dividing 4 by 2 will be 2. So negative 13 halves is equivalent to negative 26 fourths. So 5, negative 13 halves is my solution in number 14. And lastly in this video, we'll go over number 15. However, before I go over the answer to this, please remember to like this video and subscribe to my channel. All likes and subscriptions are greatly appreciated. So now that you've done that, let's work through number 15 together. Remember, we're trying to isolate that absolute value, so we're going to start by multiplying both sides by 8. And doing this, 8 divided by 8 will be 1, so we'll have the absolute value of 7p plus 4 equal to 3 times 8, which is 24. So 7p plus 4 equals 24, or it equals negative 24, since the absolute value of 24 equals 24, and the absolute value of negative 24 equals 24. So let's set up our two different equations. 7p plus 4 equals positive 24, and 7p plus 4 equals negative 24. Subtract 4 from both sides when the 24 is positive, and we'll get that 7p is equal to 20. Divide by 7 So you get that p is equal to 20/7, and that cannot be simplified. When 7p plus 4 equals negative 24, and we subtract 4 from both sides, we get that 7p is equal to negative 28. Dividing both sides by 7, we get that p is equal to negative 4. So our solution in number 15 is 20/7 or negative 4, meaning that if we plug 20/7 in for p or negative 4 in for p, this equation would indeed be true. If you have any questions, feel free to leave a comment below. And join me in the next video where I'll finish out this worksheet, completing numbers 16 through 20.